Starting from the Moragakanda Reservoir, the North Central Province Cannel stretches 96 kilometers, reaching the Mahaweli tank in Anuradhapura. This canal is designed to deliver nearly 900 million cubic meters of water annually to the region. As part of this canal, South Asia's longest irrigation tunnel, spanning 28 kilometers, is being constructed from Konduruava in Alahara to Palugaswewa in Anuradhapura.
From here at the Konduruava junction, we take our turn towards our next stop, which is the starting point of the tunnel, technically known as the southern portal of the tunnel. Let's have a look. Safety is one of the key priorities in a massive construction project like this. And safety comes always first, and we are also adhering for all the safety guidelines in this project. So let's go inside the projects after the safety precautions. We are now at the southern portal of the tunnel, North Central Canal project, and located at Konduruava, Alahara of Polonnaruwa district. And I would like to know from you, what is the speciality of the southern portal of this project?
Actually, it is a tunnel starting point, and this is located downstream of the Moragakanda Reservoir and 27.7 kilometer beyond the Moragakanda Reservoir. And here we operate TBM2, and we drive that TBM2 to the northern direction. Our northern portal, there is another TBM machine. It is called TBM1. Now it is runs direction to the southern.
I'm watching the live footage of the ongoing TBM excavation on screen at the control room, which is situated above the ground at the construction site office. So we are going to find out more details about the control room in a while.
Okay, the first thing I need to say, in this control room, we cannot operate the TBM. The TBM only can be operated for the operator in the control room of the TBM. But this room is very helpful to us because allow us, the people is sitting here, to check what is ongoing in the TBM. Here, also, we have a CCTV camera, and we can see what is happening in the northern start shaft in many places through the TBM.
We are now at the key construction site of the Northern Central Province Canal project, located in Palugaswewa, Anuradhapura district. Let's go inside and have a look. And we are now at the detailed and the dedicated factory where the concrete segments are made, and we are about to find out more details about it.
Yes. I am part of the consultant team in charge of the segment production lining. So in this factory, we have to produce around 12,000 segments. Each ring consists of 7 segments. So we have to produce around 84,000 each segments. For these segments, we are using high strength grade 50 concrete with steel fibers. So each batch we are testing to a high precise quality control. And for the production of these segments, we are using high precise steel molds up to 0.1 millimeter accuracy, and each batch we are testing as per the project specification. This is a segment manufacture factory. Here we have divided into several areas, include concrete production, rebar processing, concrete casting, coring, and the storage area. In this factory, we total have 120
local laborers. They are trained and responsible for all the activities, and all the activities are monitored and recorded.
The work site features a power generation unit for uninterrupted electricity, machine workshops, storage facilities, office buildings, and a massive central shaft.
This is a very, very important situation and also a place that we have to gain more in-depth knowledge as well. So I would like to know what is exactly happening at the North Portal starting point and the shaft and also the TBM.
Yeah, this is we call as northern start shaft. Actually, it is containing, part is the concrete structure, another part is the shotcrete structure. Diameter is 26 meter and depth is 24 meter. And shaft is the lifeline for all the TBM excavation, because it provide the air ventilation, which is breathing, and some of the equipment cooling effects, and water and utilities and electricity and power supply, illumination, and also all the manpower such as engineers, supervisors, workers, and all the material also going through this one.
We are now inside the shaft of the northern portal, and right behind me you can see the entrance of a tunnel where the TBM-1 has begun its excavation. And the TBM-1 will be moving towards the starting point of the tunnel, where the two TBMs will meet at the center of the tunnel. A massive construction, complex process and procedures. Even though there are so many other options, I would like to know why you all have selected the TBM option for this particular project.
Yeah, when we undertake major infrastructure development project in a country, we have to consider project is technically sound, economically viable, socially acceptable and environmentally sustainable. The proposed canal route pass through environmentally and socially sensitive area, including forest reserve, national park, sanctuaries and residential zone. So to minimize negative impact on both the environmental and communities, it was necessary to underground for a significant stretch, especially 28 kilometer long tunnel. Now when it comes to excavating such a long tunnel, we had to select the most suitable method considering various factors. First, from geological standpoint, TBM are better equipped to handle the specific ground condition along the tunnel trace, including mixed rock type, high water ingress. They offer better base support, which enhance safety and progress stability. Secondly, the long continuous tunnel like this, TBM are actually more time efficient and cost effective in the long run. Once setup is complete, they can operate continuously and achieve fast advance rate with high precision.
We are now at one of the most important part of the TBM, which is none other than the cutting head. And we're going to explore more about the TBM and the cutting head, and we're going to get some more information about it.
Yes, now we are in TBM to cutter head, close to the cutter head area. This cutter head diameter is 7.6, and this machine we call TBM. It is a total length 170 meter, and cutter is rotated by main drive, and main drive consists with main motor 8 motors. And when the rotation, the cutter rock start to cutting, and the cutting materials into the cutter head through main belt, and materials then go to the outside.
The cutting head, made up of 54 blades, rotates to exert forward pressure as it drills. To protect the concrete lining behind it, thrust brakes are applied slightly to the rear and sides of the blades. Once a section is drilled, the concrete lining is installed, allowing the machine to gradually advance. But the rock layers being excavated are not always uniform.
During the TBM tunneling, we want to do some
geological investigation to minimize the risk. This is one of the probe drilling machine. Using this probe drilling machine, we can do some investigation around 50-meter length. So if there is some water bearing zones or high penetration zone, rock condition, all the things we can identify using this probe drilling. Combination of all the things, we can minimize the risk. And also if there is some water bearing zones in front of us, we can do some pre-excavation grouting and control all the ground situation suitable to the TBM excavation. After ensuring the safe condition, we will allow to TBM propagate, start the excavation.
This machine work in 24 hours per day. We use 3 shifts for the 24 hours, maintenance shift and the middle shift and the night shift. Maintenance shift we have done the 8 am to 1:30 pm. At the maintenance shift we have done the cutter change, cutter inspection and probe drilling and face mapping. And the other 1:30 to next day 8 am we have done the excavation. In this project we use the type of segments in 4 types. The difference between them is the type of the steel reinforcement and the whether gasket is available or not. The right segment type is selected based on the rock condition of the face.
Now we are in TBM operator cabin. Actually, operator stay here and he operates all the TBM operation from this room. This is the very important screen of for the operator because all the propulsion systems controlled by this screen, and this is the other important part. So by the service section, TBM operator, when he operates the TBM, his direction and his angle, deviation and everything he monitor through this screen. If any issues, deviation of the path, if it is happen, that this screen will red color. Then again go to this propulsion system and again he bring the TBM to the original path.
As tunneling advances step by step, machinery transports the excavated material called tunnel muck out of the tunnel. Along this 28-kilometer stretch, the rock dust removed during excavation has been planned for productive repurposes.
We have already started to selling those materials to the external buyers, and up to date we have sold the 15,000 cubic meters tunnel mucks already, and additionally we are testing the materials to assess the use of some potential applications for another construction uses, and as well as we are considering the proposals of the extracting sand materials from those mucks.
A key priority in managing this vast industrial site is ensuring the safety and security of both the workers and the surrounding environment and community.
And here we have more than 1,100 workforce per day and 24/7 work routine. So 365 days per week, per year we have continue our work. So here we use that 2 TBMs and drill and blast tunnels, and as well as a segment factory and so many huge machines and vehicles. So we have to look after the health and safety of these all workers and outsiders and machineries and even the outside environment. Therefore, we have to comply the national and international rules and regulations and even the ADB safeguard policy statements. So all these things we are combinedly use here. And additionally, so we have the separate hazards like oxygen depletion carbon monoxide or methane emissions inside the tunnel. So we have separate methods, like we monitor all these gases inside in every 3 shifts. So finally we hope to send our workers home after the work day, end of the day safely.
28 kilometers stretched, this magnificent tunnel will usher in a new era of irrigation, bringing life, giving water to nourish both flora, fauna and our next generations to come. A true milestone in engineering, it stands as a legacy for the future.